All right, so what we are going to do here, we are going to be using these very same variables that we've been using all along, the very same GDP, PCE, and PDI. Those are the ones that we are going to be using. But then they haven't been converted to logs. Since these values are large, all of them, if I can open it as a group, I'm sure you can see these are big numbers. So we need to log them. We need to log them, right? We need to log them. So let's quickly do that before we use them. So lean GDP is equal to log GDP. Lean GDP is equal to log GDP. Log GDP. Right. Then we do the next one, lean PCE. Lean PCE is equal to log PCE. Log PCE. Then the third one, lean PDI. PDI is equal to log PDI. Log PDI. Right. So we have our variables in logs. Now, in the model that we want to estimate, I'm going to write it like this. So GDP is explained by, this is the ARDL model that we are going to use. GDP is explained by PCE, and PDI. Then the PCE, this is what we are going to be doing. PCE is explained by GDP, and PDI. And PDI is explained by PDI is explained by PCE, and GDP. So these are our three equations. If we write them in the similar fashion to how they were appearing in the notes, you have three equations where GDP is explained by this. This is the very same way you write FR, right? So this could be what? ARDL, or FR. It's the same way you write in FR. And if your variables are co-integrated, you just add an error correction term to each of them, to each of these three equations. That's it. Which is similar to a VECM, right? That will be a VECM. But here we are doing it under the ARDL setting, right? I hope you are following. So GDP is explained by lags of itself, PCE, and PDI. PCE is explained by lags of itself, GDP, and PDI. PDI is explained by lags of itself, PCE, and GDP. That's all we are saying here. Then let's go on.
Yeah.
Yeah. Okay. So let's try to do the estimations. Now to do the estimations in ARDL, we are going to choose the first equation first with the GDP as the dependent variable. Next, we will choose PCE as the dependent variable. And lastly, we will choose PDI as the dependent variable. So GDP is the dependent variable, PCE, PDI. PCE, PDI. Right, so you right-click on the highlighted variables, open as equation. Open as equation. Then when you are here, you go to this down arrow, you click it, then you see different methods that are there. Then you go to pick ARDL, autoregressive distributed lag model. That's the one you pick, you click that. And this window comes up. In this window, you can estimate a model with a constant. You can also estimate, you can use the archaic information criterion, the Schwarz, the HQ, the adjusted R squared. You can do that. You can choose whatever you want, but we are going to leave the archaic there. Then here, you can also choose the white arc. For example, if your model is giving you problems with the heteroscedasticity, you can choose the white or the hack new West test. That can help you resolve the heteroscedasticity problem. So I'm going to go with the hack in my estimations. Then we go back to the specification. Let's allow, say 5 flags, maximum 5 flags. See what we get. Then the method is given. We are not going to fix the number of flags. We'll keep them at. We are requesting Eviews to select the optimal lag length for us. So we choose automatic selection. So Eviews will choose the optimal lag length for each variable that is in our model. It will choose the optimal lag length for each variable in our model. Then we click OK. This is what we get. Huh. Right. So the model that has been chosen here, what this means is, I'm sure you can see the dependent variable, the method is ARDL, then the observations is 29, then the selected model is ARDL 101, because we have 3 variables. When we were talking about the ARDL PQ, we had 2 variables, where the P was the lag of the dependent variable, and the Q was the lag for the independent variable. But now we have 3 variables. So the 1 is the lag of the dependent variable GDP. I'm sure you can see it is a lag of 1 here. Then the 0 is the lag of PCE. So we are only considering it in levels. I'm sure you can see that. So it doesn't have any lag. Then the PDI is a lag of 1. We have it in levels and lag of 1. So this is what defines this. So this is ARDL 101. This is the optimal model that has been chosen by Eviews for us. This is the optimal model chosen by Eviews for us. So, having said that, how do we test for co-integration? So to test for co-integration, we use, remember, we used the first lag of the dependent variable. Okay, if you still remember in that equation, which I called unrestricted. Okay, let me just show you how to do it. To test for co-integration, you go to View. Then you go to ARDL diagnostics.
Bounds
Then
test.
ARDL diagnostics. Then you go to bounds test for co-integration. So this is how you do your co-integration test. So if you click bounds test, this is what you get. Now, what you get, remember I was talking about the upper bound and the lower bound when we were discussing this. So the test, you do it, you look at the asymptotic F values, these ones here. Right? Then the first two numbers, okay, these first two numbers is what, 5%. You can do the test by using the F test or the T test, right? So at 5%, 10%. So at 10%, this is the upper bound, 4.140, lower bound 3.170. Using the T test, the lower bound is 2.5, the upper bound is 3.2. If you go to the second one, this is the 5%, 5%. The upper bound is this one, 4.8, lower bound, upper bound, lower bound. And at 1% level, the upper bound, lower bound, and so on. Now comparing our F statistic, what should I do? It looks like, all right. Right. Let me go back to those results. Bounds test, right? So comparing this F statistic, 2.3, with the upper bound at 10%, upper bound at 5%, upper bound at 1%. This figure is smaller than all of them. Even if you compare this one, the T values, this T value is smaller than is greater than all the T values that are there, right? So it's a way, but let's limit ourselves to the F test, because this is the one that we discussed in the notes. So the F test is 2.3. It's smaller than all these F statistics at different levels of significance. So if it is small, what are we saying? Is there co-integration or no co-integration? Because the null hypothesis is there is no co-integration. The alternative is there is co-integration. So what's our conclusion in this case? Since the calculated F statistic is smaller than all the lower bounds at the various levels of significance, is there co-integration or not?
There is no co-integration.
That is true. There is no co-integration. So if there is no co-integration, it means that we have to estimate so there is no co-integration. Okay, so we have to estimate, just a moment. Let me experiment first. Okay. what we've got is not good enough for the explanation I want to give. So let's try what? To fix the lux. I will fix the lux to 2. Yes, of course, it goes against what I was explaining, that the lux need not be the same. But let me fix them at 2. If you fix the lux at 2, these are the results that we get, right? Now, let's try to test for co-integration using this, using the bounds test. Still, there is no co-integration. What if we fix the lux to 1 and estimate, right? Let's test for co-integration again. Still, there's no co-integration. It looks like I've picked the wrong data. I picked the wrong data. This is not working. Let me pick the correct data that will help us in what we are doing.
Sorry, sir.
Yes.
You didn't use if there's no co-integration.
You are saying?
No? You said if there's no co-integration, you can use the the model.
The ARDL.
Yeah, the ARDL. But if there's no co-integration, you must
No, if
estimate
there is no co-integration, you don't add the error correction term.
Oh, okay.
Yes. You don't add the error correction term. All right. Are you still seeing what I'm sharing?
Yes, sir.
Yes, sir.
All right. Okay, let's try to go for it again. The way we had changed the variables to logs. What are you seeing on the screen now?
Still the bounds test.
Still the bounds test. Okay. All right, let's see. I'm trying to the bounds test. All right. There's something things are not coming out right here. So let me try to change this and see if so. So I'm going to try and estimate again. Right. This is correct now. Have you seen what I've done? I just picked the 3 variables. And this is what helps me explain those things that we were doing. I'm sure you can see that the model chosen here is 5, 2, 4. We have 3 variables. So the dependent variable has been given 5 lags. I'm sure you can see that. Then the PCE has been given 2 lags. This is these 2. Then PDI has been given 4 lags. So this is the model that we use to test for co-integration. I'm sure things are going to be different now. So this is the model that has been chosen by Eviews for us. I hope you have followed what I've done. Then to test for co-integration, you now go to the bounds test, right? The bounds test, still there is no co-integration, right? Okay, so that if that is the case, then we are going to keep it that way. There is no co-integration because 1.7 is smaller than 2.7, which is the smaller bound for at 10%. 2.170, the smaller bound is 10%. So there is no co-integration. So if there is no co-integration, what are we supposed to do? What are we supposed to do? Look carefully at what I'm doing now. I'm sure you can always do this. Now, what you do is we go back to the results. And I am going to go to, we have established that there is no co-integration. Then you go to error correction results. There's a reason why I'm doing this. What I want from here is this information. Remember, our dependent variable is GDP, which is explained by lags of itself, and so on. So from this error correction results, there is some information that I'm going to extract. You must get this right because it's a trick that you need to know. So I'm going to copy these variables here. I'm going to copy those variables, right? I will copy those variables. And I now go to quick and choose estimate equation. Then I just paste that information I copied. So this is the model, the best model that was chosen by Eviews is the error correction form. But we are not going to estimate the error correction equation here because we established that our equation is not, the variables in the equation are not co-integrated. But we know the dependent variable is dGDP. What I picked from here are only the explanatory variables. These are the explanatory variables. And the dependent variable is this D ln GDP. So it's the one that you have to write first. See where I've put my cursor? Before the first explanatory variable. So that is where I'm going to put my dependent variable. So D ln GDP is my dependent variable. I create space. So the first variable listed is the dependent variable, this one. All the other variables that come after this variable are independent variables. That's the point I'm trying to make. So to make life easy, you just copy instead of typing them one by one in the way they are appearing now. You just copy and paste instead of typing them one by one. Then you add the independent variable because you cannot copy it together with the independent. You cannot copy the dependent variable together with the independent variables. So since we have established that there is no co-integration in this model, this is the model that we are going to estimate. This is the model that we are going to estimate. So let's estimate it and see what we get. We estimate it. And this is what we get. And we do the estimation in OLS. So these are the results that we get from that estimation. I'm sure you can see these are the results that we get. And you can improve these results by eliminating those lags that have large probabilities. For you to come up with a parsimonious model, you can come up with a parsimonious model. I explained what a parsimonious model is in the previous lecture. So we have this variable with a high what probability, then this one with a high probability. We are going to remove them one by one and see what happens. So we'll remove the second lag of GDP and see what happens. Let's remove the second lag of GDP. Where is the second lag of GDP? This second lag of GDP, we remove it and re-estimate. Right, I'm sure you can see the results have already started improving. Then we can also remove which one? The current value of PCE, we We can remove it because it's the one with the largest p-value. We are trying to create a parsimonious model. You can also test for the redundancy of these variables before removing them. And they will be redundant, obviously, because they are highly insignificant. Now, as you can see, the results have improved drastically. Can you see that? The p-value for GDP, the first leg of GDP, I think, also needs to go. The first leg of GDP needs to go. First leg of GDP needs to go. Okay. We've removed it. And I'm sure we can leave it as it is now. So we have GDP, third leg, fourth leg are the ones that are explaining, which means GDP is explaining itself with a lag. Then PDI is also explaining. Okay, then the first leg of PCE is explaining that. Then PDI, all the lags of PDI, I'm sure we can remove the last one. It's not important. It's not significant. We can remove the last one for PDI. If you remove that one, right, I'm sure you can see everything appears fine now. But then the third lag is also not significant there for GDP. I hope you are following. All right, I think we can keep it this way. So fourth lag of GDP, then PCE. So the fourth lag is the one that is significant. So PCE, as you can see, is significant and positive. You can interpret this as it is by using the what? The simple OLS way in which you estimate. You can interpret this that way. Then if you look at PDI, all of them are positive and significant. PCE is positive and significant. GDP is positive and significant. After we have eliminated those variables that were negative and insignificant. So we've remained with a model that we can interpret. Then you can test your causality. C2 is equal to 0, right? You can to test whether this Granger causes, and it Granger causes because it's significant. Then PDI is C3 is equal to 0. It Granger causes because it's significant. Even PDI, you can see the three PDIs, two of them are highly significant, while the other one is marginally significant at something close to 10%. So this is also Granger causing GDP. Maybe we can quickly do that so that you see what I'm saying. So this is what you use to do your Granger causality now. You go to coefficients diagnostics, world test. Then we are saying C2, that's the coefficient of PCE. C2 is equal to 0. That's the Granger causality, because it is only one lag that is explaining GDP. And here, using the F test, you can see that PCE Granger causes GDP at 1% level of significance. Then to go back to the results, to do the other test for C3, maybe we'll go back to the results first. C3 is what? No, this is what? PCE. Then the coefficient of PDI is C3, C4, C5. C3, C4, C5. So you go to coefficients world test. So you do your C3. C3 is equal to C4. C4 is equal to C5. Is equal to 0. So this is your null hypothesis that PDI does not Granger cause GDP, right? You estimate, and as you can see, your F test highly significant. So PDI, Granger causes GDP at 1% level of significance. So this is how you do it. And then you're going to interpret your results. Given what we are doing, the explanations I'm giving, I don't expect anyone to struggle when it comes to your mini thesis next semester. You need to understand this information, our practical sessions, and the lecture notes in and out for you not to struggle. So that's it. That's how you come up with a model that you can interpret. Remember, we started off with we estimated the long run model, right? Estimated the long run model. Then we tested for co-integration and found that there's no co-integration. And then we specified the model without an error correction term because there is no co-integration. And this is the one that I've now reduced to a parsimonious model by the method of elimination, which I taught you. So with such results, you have many stories to tell. Then you can also do those other usual tests. Let's do them because we still have the time. The usual test, your normality test. What is it telling us? The residuals are you guys, the residuals are normally distributed. This is greater than 5% the probability. The residuals are normally distributed. Serial correlation, you also test that. And you look at this, greater than 5% probabilities, the residuals are not serially correlated. Then you do the next test. You can use the H test. Once again, the probability values are greater than 5%. The residuals are not homoscedastic. Then you go to your Ramsey reset test. Your Ramsey reset test is telling you that your model specification is excellent. The model is correctly specified because the F statistic is greater than 5%. Then you go to what other test? The sum of squares test. It shows that the parameters are stable. What about the sum of squares test? The sum of squares test it also shows that your parameters are stable. So all the tests that we have used, 100% correct. The reason being that we have estimated a parsimonious model where we eliminated those variables that were redundant in explaining our dependent variable. That's the reason why all these results are perfect. I'm sure you can see it's the first time that we are getting perfect results from all the tutorials that we did in the past. We are getting perfect results. All the tests, normality, heteroscedasticity, autocorrelation, Ramsey reset, sum of squares, all of them are perfect. There is no problem. It's because we have used the correct specification of the model. And by removing the redundant variables, we were able to improve our model. All right, so that's it. I will name this. So next, next we want to estimate. We want to estimate a model with PCE as the dependent variable. So PCE is explained by GDP and PDI. That's the model we want to estimate. Let's see if we are likely to get something different here. This is the equation. Then we go to, you choose, you specify the model, then you go to ARDL. And by doing this, ARDL, by doing this, let me increase the number of flags to 5. Right. You can leave them at 4. It doesn't matter. Because in what we have done, there was no lag of 5 or lag of 4 or even lag of 3. I'm sure the maximum was a 2. Right. So you estimate this. So this is your equation that you use to test for co-integration. The current lag of GDP, the current lag of PDI are also explaining PCE. So these are your results. What do we do next? Next, we test for co-integration. You go to view, then ARDO diagnostics, then you choose bounds test for co-integration. And as you can see from these results, let me expand them. The F statistic is 22. The calculated F statistic is 22. And it's bigger than the upper bound at 10%, bigger than the upper bound at 5%, bigger than the upper bound at 6%. Which means the variables are now co-integrated. The variables in the model are co-integrated. There is co-integration. Now, if there is co-integration, what are we supposed to do next? That is what I'm going to show you now. What are we supposed to do next? There is co-integration, right? There is co-integration. Then the next thing you do is you go to, this is something new. You go to ARDO diagnostics once again. Then you choose co-integration relation. Co-integration relation. You pick that and you get this information here. And on this information, you right click to edit because we want to copy this. This is co-integration equation. This is the co-integration. This is the equation that you use to estimate the errors in the model. This is the model, the equation that you use to estimate the errors. So I'm going to copy this equation. Listen carefully. I copy this equation, right? Then I copied the equation. So look at what I've done. I copy. Then this comes up. You just click OK. Then you go to quick. I want to generate a series. The series that I want to generate are the errors. So I click on generate series. And then paste the equation that I copied here. And as you can see, there is a gap between this plus and the 45. So I want to close that gap. You close the gap. And the errors that we want to generate, we are going to call them ECT. We are going to call them ECT. So we remove the EC that was there. We call them ECT. Then click OK. And if you look here, the ECT has been created. This is the ECT. This is the variable of errors that has been created, right? So that's it. Then we are not done yet. I go back to the results. These are the results. Now, what you do next is you go to the error correction model. In this space here, in this equation, you go to the error correction results. Click here. And this is the equation that we were just looking at. You scroll downwards. These are the error correction results. Some people prefer to report these results as they are here. I'm sure you can see that PCE is explaining itself up to the second lag. The model chosen is up to the lag 3. Then GDP up to lag 5. Then up to 5 because we are saying GDP in levels. Then 1, GDP in level is 1, 2, 3, 4, 5. That's where this 5 is coming from. And for PCE, it's in PCE, which is the dependent variable, then 1, 2. So the dependent variable plus 1, 2, which is 3. That's where the 3 is coming from. Then for PDI, the maximum lag is 2 here, but we are starting from the current value of PDI, the first lag and third lag, which is 3. That is where this 3 is coming from. So some people, like I said, report these results here. They report these results. And as you can see, these are nice results. The error correction, this is the error correction term, coint Q, is negative and significant. Then the PCE and it's like there is one significant, one not significant. Then GDP, all of them are almost significant except for one. Then PDI, all of them are significant. These are nice results, but we are not going to use these results. What I'm going to do from here is to copy these variables. I'm going to copy the explanatory variables as they are. And we remember that our dependent variable is PCE. Then I copy this, copy. Okay. Then you go to quick estimate equation and paste. Right. Remember, I said the first variable is our dependent variable. So we need our D PCE. Then you create space between it and the next variable. You create space. Then the last variable that we want to add is the error correction term that we created earlier, ECT. ECT lagged once. You should not forget to lag it once because that's the correct way of doing it. So we now have our complete error correction equation, and we are going to estimate it in least squares, ordinary least squares, using ordinary least squares. Because these variables are differenced, meaning that they are all stationary. Because we are using different variables here. They are all stationary. So we can apply ordinary least squares to estimate this equation. That is something that I explained previously, that you can use OLS if all your variables are integrated of order 0, or if all your variables have been differenced and they are integrated of order 1, right? You can use OLS if all your variables have been differenced, because the difference variables do not have trends from what we did previously. So I will estimate this. First, I name this equation, equation 2. These are the results that we get. These are the results that we get. Our error correction term is that it's negative and significant, but way greater than, there's something wrong. Something very seriously wrong. Can you see the coefficients which are huge? These are very big coefficients. The standard error is very big. All those things very big. There's something that we did not do right. I'm trying to think what it is. Yes, it's the dependent variable. I wrote it wrongly. It's supposed to be lean PCE. I just wrote PCE. Can you see that? So that's where the mistake is coming from. If you come up with such a problem, you must think quickly so that you see where you made the mistake. So let me correct it. You will see the results will change. So LN PCE. Then we estimate. As you can see, the standard errors are now normal. The coefficients are now small. The t values, then your results. I'm sure you can see what I'm doing. Then the coefficient is negative and significant and even less than 1. In the previous case, it was greater than 1. Now, the next thing that you do here is to eliminate those variables that are highly insignificant. Highly insignificant. Right. So it's what? The second lag of GDP is highly significant. No. The first lag and the second lag of GDP, right, are not significant. So let's remove the first lag and second lag of GDP and see how the results change. We said what? Second lag and third lag.
First leg and second leg.
Okay, let's look at this side by side. First lag and second lag. Okay. That's it. So we remove those and re-estimate again. These are our results. Do we need to do anything further? I'm sure that this is enough. This is enough. We can't do anything further. Let's just leave it as it is. No, but there is a problem somewhere. Let's test this PDI is not significant. Let's try to remove it and see how the results change. PDI. First leg of PDI. First leg of PDI. We remove it. Then is there another variable that is not significant? Okay. All right, we can leave it as it is. As you can see, PCE, this is GDP, and this is negative. It's being negatively affected by GDP. Yes, it's being negatively affected by GDP. Then it's being negatively affected by PDI. ECT is negative and significant. It's fine. But we are interested in Granger causality. So let's just ignore everything else. All right. Before we do the Granger causality, let's do the diagnostics first. Let's do the diagnostics first. This is okay. There's no residuals are normally distributed. Then you go to serial correlation. The residuals are not serially correlated. This is greater than 5%, these probabilities. Then you go to heteroscedasticity. There is no heteroscedasticity. There is homoscedasticity because the probabilities are greater than 5%. I'm sure you can see what I'm doing. Then Ramsey reset. The model is correctly specified because the probability of the F test is greater than 5%. I'm sure you can see what I'm doing. Then
yes, we can see, Pro.
Yes. Then
It's like
this
for
one.
the test.
Oh, okay. Then the Kusam test is fine. Then let's do the other one, the Kusam test, the Kusam of squares test. The Kusam of squares test. There's a slight, but this is acceptable because only a very small portion, a part of the blue line is cutting the red line. So this is acceptable. There's a way in which you can interpret this. This is acceptable. So once again, the results that we've got are actually almost perfect, save for this small part, which is this small part. But they are almost perfect because all the other tests are giving us the results that we should expect. Then next, let's do the Granger causality test. Next, let's do the Granger causality test. We go back to the results. Go back to the results. Right, to test whether GDP Granger causes PCE, you use C3, C4, C5, C3 to C5. So let's do that. C3 to C5. You go to view, coefficients, diagnostics, all the test. So C3 is equal to C4 is equal to C5 is equal to 0. So that's our now hypothesis. This is supposed to be C5. C5 is equal to 0. You test, and your F statistic is showing that the GDP Granger causes PCE at 1% level of significance. That is all you need. So, like I said, when you are using these tests, when you are using the ARDL and the VECM, you ignore the signs on the coefficients because your main task is to do Granger causality tests. So the signs do not matter. You want to interpret the Granger causality. So this Granger causality test is telling us that GDP Granger causes PCE at 1% level of significance. So these are some of the small explanations that those people who don't attend lectures don't get. And when they listen on their own, they may skip some such things because they are just listening to the recorded lecture. All right, so That's the test. Then let's do the other one for the other variable. For the other variable is PDI. You count 1, 2, 3, 4, 5. So for PDI is 6, 7, 6 and 7. Obviously, there is Granger causality because, as you can see, the results have improved. Right? The number of variables that are significantly expressed have improved. That's why I'm even concluding before testing that it Granger causes. So we said C6 and what? 1, 2, 3, 4, 5, 6, 7. So we do the Granger causality test once again. C6 is equal to C7 is equal to 0. C6 is equal to C7 is equal to 0. Right? Once again, PDI, Granger causes PCE at 1% level of significance. That's it. Then I save this. Now let's do the last one. So we've done our Granger causality tests, and I even showed you how you generate the errors. That trick, you need to revise it. How you generate the errors. Let's try to do the third one and see if we can repeat what I did with the second one. Because the first one was straightforward, it wasn't co-integrated. So we did not use the error correction term. But the second one, we used the error correction term because there was co-integration. Okay, so the third equation, PDI is the dependent variable now, being explained by GDP and PCE. Open as equation. You go to ARDL. In ARDL, we are going to increase the lags to 5. That's it. Then you estimate, and these are the results you get. These are the results you get from that estimation. The model chosen for GDP, there are 4 lags for GDP. For PDI, 4 lags for PDI. Then for GDP, there are 5 lags. For PCE, there are 2 lags. So this is the model chosen by Eviews for you. In fact, Eviews can actually choose a better model for you than you can do yourself. So you have to give Eviews a chance to pick the model for you. If you pick the model for yourself, then you have to do a lot of adjustments. And in the process of doing that, you may make mistakes and not come up with the best optimal model. So this is the what? The model. Then we go to ARDL diagnostics. Bounds test first. Bounds test first. So the bounds test is telling us there is no co-integration here. Was 2.8. Okay, there is co-integration. Okay, no. This is lying between 2.6 and 3.5 at 10%. And is smaller than the lower and upper bound at 5%, smaller than the lower and upper bound at 1%. So these results here are also supposed to be reported. If you are writing your mini thesis, you report these results as well. So there is no co-integration. So for the model with co-integration, rely on what we did with the second equation. So I would advise you to listen to this recording before you forget, so that this information sticks in your head. Okay? So there is no co-integration, which means we are going to estimate the ARDL without error correction term. So we go back to our results. In our results, what do? We go to view, then go to ARDL error correction results. And we only need this to get the best model to estimate in OLS. And you edit and then pick these variables, these independent variables. And the dependent variable is ln PDI, by the way. Don't forget that. So we copy this We copy this. Then we go to, we copy this, then we go to quick estimate equation. Then we paste what we copied. Then the dependent variable, you scroll up. The dependent variable is what? Lean PDI. So it's D lean in PDI. PDI, create space. We are not going to add the error correction term because the variables are not co-integrated. So this is the best model chosen by Eviews. So we just go ahead and estimate this model. We just go ahead and estimate this model. And this is what we get. These are our results. These are our results. So we remove those that are highly insignificant. So one of them here is GDP, second lag of GDP, and PCE. Second lag of GDP and PCE. Right? We remove those two. Second lag of GDP and PCE, this one. Then click OK, we estimate. And this is what we get. Still, the third lag of the first lag of GDP is not okay. And PCE, we cannot remove it because if we remove it, then everything goes. So we can remove first lag of GDP and third lag of PDI. Third lag of PDI, we can remove that. Then the other one, what did I say? I've removed third lag of PDI, then the first lag of GDP. We can also remove that. Which means the GDP is explaining these other variables from the third lag onwards. I'm sure you noticed that has been the case in all the three cases that we've looked at. Then you estimate. So here we are not going to change anything. Okay, we may, but no, we can leave it as it is and then do our Granger causality using this. So we'll be testing these two is the what? Granger causality. Then these two, this one is causality, and this one to test for causality as well. But before we do causality tests, let's do the diagnostics once again. The diagnostics normally distributed. The residuals are normally distributed. Then we go to serial correlation. There is no serial correlation. I'm sure you can see that. There is no serial correlation. Then we go to the arch test. There is no heteroscale assist. I'm sure you can see that. Then we go to Ram's reset. The model is correctly specified. All the p-values are greater than 5%. Then you go to what? Recursive. This is perfect. The parameters are stable. The sum of squares test. Sum of squares test. As you can see, perfect, 100% perfect. All our tests. And when you are doing your own study, if you come up with results like these ones and interpret them correctly, there's no reason why you should fail. You will definitely pass. So the thing is, you have to follow what we've been doing together very, very closely. Understand the stuff that we are doing. Because if your results come up the way we are coming up with this information, then there is no reason why you should fail. No reason, provided you explain your results adequately. So 100% all the tests are perfect. The only one that gave us problem was that one where we had a small bump on the red line. That was the only one. Otherwise, all the other tests for the three models we've estimated are perfect. Right, then the Granger causality, we want to test whether GDP Granger causes that. So we pick 1, 2, 3. C3, C4, C5 for PC, for GDP Granger causing PCE. So C3, coefficient diagnostics. So C3 is equal to C4 is equal to C5 is equal to 0. GDP Granger causes PDI at 1% level of significance. That is what we found. Then to do the last test, you report these results as well. The last test is 1, 2, 3, 4, 5, 6. So C6 is equal to 0. To test whether PCE Granger causes GDP, PDI. So C6 is equal to 0. This one may not Granger cause because it's not significant. So this is it. The F test is telling us that PCE does not Granger cause PDI. That's it. So that is the explanation that I wanted to give you with regards to this. So we have estimated 3 models. One for GDP, which was explained by itself, PCE and PDI. Then the other model for PCE, which was explained by itself, GDP and PDI. Then the last one was the PDI equation explained by lags of itself, GDP, and PCE. So with that, we have come to the end of our lectures. We've come to the end of the lectures. If I already said that you can come and consult on Mondays between 2 and 4. That is what we agreed in our previous lecture. If you have some issues that you want to discuss with me, you come and see me on Mondays between 4 and 6. But then, if you want to see me, I think it's good that you tell me that you want to see me in the morning. You can send me a text that you want to see me so that I go to the office, because I wouldn't want to go there and wait for people who never come. Right? So you just tell me before 2 o'clock that you want to come and see me so that I go to the office. Okay? So with that, we've come to the end, and I wish you the best. And just to reiterate what I said earlier, if you want to pass the examination, you must know this stuff in and out. And for your information, there is nothing difficult with everything that we have done. There is nothing difficult. You only fail if you choose to do so. If you want to pass, you will definitely pass. And you know what to do. You just have to read, understand. That's it. And you will pass. So with that, if there are no questions, we've come to the end of our lecture.
Professor,
Yes.
what is test 3 going to cover?
What do you need test 3 for? You have qualified for exam, haven't you? There are only 3 people that you are not qualifying to write. All the other people are qualifying.
So if we want to improve our marks, we can't write test 3.
You want to improve your marks.
Mm-hmm.
Okay. Is that the general feeling of everyone?
Yes, sir.
You want to improve your marks. Okay. But test 3 will be difficult. And it will cover everything that, yes, it will cover everything that we have done. Because there is no reason for me to give you a test 3 which doesn't cover all the things that we have done. So it will cover, if everyone wants to write, it's fine. But it will cover everything that we have done. And I will make it as close to the examination as possible.
And then you
And you-
take the marks for the best 2, sir.
Yes. Those whose marks would have improved will tell me if their marks have improved, then I can change their marks.
Okay.
But
Thank you.
it won't be a straw in the bag. It will be as close to the exam as possible.
That will be good for the preparation.
Yeah, that's fine. That is true.
Yes.
So, yes, you have to agree with your class rep when you would want to write. Then I prepare the test and you write.
Yes,
It
sir.
can be next week. You can write next week.
Sorry, sir. We have a date. I will communicate it with you.
Yeah, all right. So you have to agree and tell me. It's okay.
Okay, sir.
All right. So with that, we've come to the end, and I wish you the best in the final exam and the test.
Thank you.